This is 2.2 graphs of functions. We've already talked about what a function is and about the function box, and just we've already kind of mentioned about the different types of functions, but here it is in one lesson here where the linear functions are anything basically as a line, y equals mx plus b. A constant function is literally a horizontal line, y equals 7, y equals -3. It is not x equals, by the way, it's just y equals, because otherwise it wouldn't be a function. Power functions are anything that has a power or an exponent with it. So x squared, x cubed, x to the fourth. Root functions are, square roots, cube roots, that kind of stuff. So those are the basic common types of functions that we've dealt with so far. I also wanted to mention, if you in our textbook, page 202, it shows you different types of functions and what they actually look like. Those are the basic functions. I do recommend that you at least look at it, be familiar with the different types of functions. Without a graphing calculator, you should basically know what a root function looks like, or a power function, or a constant function, or a linear function. You should know what the functions generally look like without actually doing the XY chart, and definitely without using the graphing calculator. All right, so something I do want to point out. So if I gave a function y equals 1/2 x cubed minus 2x squared plus 4, I just simply make an XY chart. You guys can do the same. I just plug those values in, and then I graph them. And you should know a cubic function basically looks like this in general format, like that. Any cube, whatever these values may change, that's what a cube root looks like. A cube function looks like. So this over here, the second graph, the reason why I want to point this out to you is because sometimes, notice over here, it's all real numbers. The domain is all real numbers. I just plugged in anything I wanted to, and I would get the domain. Well, here, notice I restricted the domain. So I only want the domain of that function from 0 to 3. So literally the XY chart would include 0, 1, 2, 3, and any number in between there, by the way. So don't forget about, you can always plug in 1.1, you can plug in 2.7, but you can plug in any numbers between 0 and 3. You don't have to just plug in the nice numbers, but it's any number between 0 and 3, and then you find the y values, and then you graph that. And then, of course, then I can ask you to evaluate the range of that function as well, based off of whatever the domain is set for. So remember, the domain is your set of x values or your input. The range is the set of y values. So look on the y line, how low does it go compared to how high does it go? And that's considered your output. All right, so notice if I graph, look down at the green. So here I have y equals x squared, y equals x to the 4th, y equals x to the 6th, and I could keep going, y equals x to the 8th, x to the 10th. If you graph them, the graphs actually look very similar to one another. And so if n is even, so x, 2, 4, 6, 8, then the graphs are similar to each other. So basically, this is called the parent function. And then so everything's going to be related somewhat like that. So even if I had some really weird function like x to the 8th plus 4x to the 6th minus 3x to the 5th plus 2x to the 3rd minus 9x plus 7. Generally speaking, the higher exponent right there, the x to the 8th, even this weird function is going to look similar to the x squared. It's similar. Again, we can graph that and look at it, and you're like, well, how does that look similar? Well, in general, the endpoints are going to go up. Like if x squared is going to go up like that, then the endpoints will also go up. And then what it does in between may look, like this or something. Depending on all the powers and all that kind of stuff. So you just need to be familiar with, in general, if the higher exponent is even, they're all going to look like y equals x squared. Well, likewise, if you notice what I have here, likewise, if n is odd, all the graphs are similar to each other. So it's similar to y equals x cubed. So x to the 5th is going to look similar to x to the 3rd. x to the 7th will look similar to x to the 3rd. So again, depending on the, it may have more loops and all that kind of stuff, but the end points, the end parts of the graph will look very similar to the base function or parent function. All right, so one of the things we've talked about as well, to see if it's a function should only cross once with a vertical line. So it's called the vertical line test. So here I have 3 graphs, and I want to see if they're a function. If you could draw a vertical line and it crosses at more than one spot, it's not a function. So if I just draw a vertical line, notice it only crosses at one spot. And the same thing here, same thing there, same thing there. It only crosses at one spot. So yes, this is a function. Same thing, let's go to the next one. If I draw a vertical line, vertical line, vertical line, vertical line, notice it only crosses at one spot. So yes, it is a function. And this, if I go to this, if I draw a vertical line, notice it crosses at 2 spots on that line. Same thing there. So this is not a function. So it's an easy way to tell if something is a function. If you remember the definition of a function, and for each value that you substitute in, only one number should come out. So just so you understand why that is. So let's just say this is the point. Let's just say that's evenly at 5, 5. And this is at 5, -7. So notice if I put 5 in, I got 5. But if I put 5 in, I got -7. So that's not a function. So remember, for every input, there should only be one output. So that's why you do a vertical line test, and it should not cross more than one spot. All right, so let's talk about a piecewise function. A piecewise function is different formulas for different domains. So this may look a little weird, but here you have a function f of x, and if x is less than or equal to 1, then we're going to graph this function. If x is less or greater than 1, then we're going to graph this function. So if I graph this blue function, and notice what you're going to have to do is create an XY chart for the blue and create an XY chart for the red. And by the way, sometimes there's three formulas or 4 formulas or whatever it is. It's called a piecewise function. So for the blue, notice x is less than or equal to 1. So 1 and then 0, then -1, then -2. And we're going to substitute those numbers in to be able to find out what those numbers are. So this would be 1, this would be 0, this would be 1, this would be 4, and this would be 9. And then if we graph that, to be able to do that, so we're going to have 0, 0, 1, 1, -1, 1, -2, 4, -3, 9. So you guys know what the idea of a parabola is going to look like. It's going to look like this, but notice it doesn't go past 1. So don't do 1.1. You can't do 1.1 on x or even 2. You can't do those because it's less than or equal to 1 is all you can do to be able to do that. So it's kind of like a half a parabola that you're going to be involved with. Now let's look at the red XY chart. Again, this is x is greater or equal to 1. So 1, 2, 3, 4, 5. So if I plug 1 in to this function, 2x plus 1 would be 3. Plug 2 in, that's 5. Plug 3 in, that's 7. Then 9, and then 11. So if I graph those, 1, 3 is this. So notice I'm going to put an open circle because notice it's greater than. It does not include that. This does not include this point. And then 2, 5, 3, 7, 4, 9. And this is basically going to be a line or array going that way. So notice I graphed, it's one function. This actually passes the vertical line test. So if you try to draw a line, it only crosses at one point everywhere that you try to draw it. So this is a function. It's just defined with this formula for that domain. It's defined with that formula for this domain.